Welcome to the world of more max-min problems. The sum is 12. We want to minimize and again, you need to get it down to one variable by using the other information. Looks like they're completely symmetric, so it doesn't matter which one you change. Does it matter whether you FOIL it out? Not really, because the chain rule and foiling are just about the same for a binomial. Let's see. But you have to remember the chain rule. Yeah. Yeah. Sorry, had a brain fart. No, what does y equal? Okay. So the two numbers are both 6. This happens a lot with max-min problems. For instance, if you have a rectangle that you're trying to maximize the area, turns out the dimensions are equal, so okay, get it down to one variable, perimeter is the distance around the outside. We haven't taken the derivative yet. So it shows a square. Oh, look, it's a square. Okay, another one of these square-based boxes, but this one doesn't have a top. So or at least not that we're going to count. So let's see. We want to weigh as little as possible, and the weight is not the volume. The weight is related to the surface area. So this is just like the cost, except everything's being made out of the same stuff, so you don't have to worry about multiplying to get a cost. So surface area, 1x squared, but not the other one. This time the volume is 500. Should be getting better at these. Got 2,000, 2,000 over x. So x is 10. Do they want dimensions? Yes, they want dimensions, not the actual volume. Okay. Or the surface area. So when it's round like the cylinders, you have to sort of just say radius is this. With a box, we just say x by x by h, so. Okay, next. We're designing a rectangular poster, 50 square inches of printing inside, 4-inch margin at the top and bottom, 2-inch margin at the side. The inner dimensions have the 50. So I'm going to call the inner part x by y. And then the outer dimensions, which is we're trying to minimize the paper, let's see, it's x in the middle and then 2 and 2, so x plus 4 by y plus 2 4s, so, okay, fine. The inner part is 50, so maybe I'll foil before I start plugging in. What do you think? Sure. I hate multiplying with fractions. No, I don't. I love it. XY is 50, so I just... What do we want? Oh, the dimensions for the whole paper. We want... So we want x plus 4, 5 plus 4 by 10 plus 8. So make sure that you answer the question they actually ask for. All right. What is this doing in here? Oh, well, maximum height. Okay, fine. So the velocity is the derivative of height. We've seen that before. Incidentally, this thing, let's see, what does it start at? Oh, look, it starts at a height of 80. So without even looking at a calculator, I can say it goes poof. Okay, so looking at this, maximum height happens at one point. The height equals 0. So we'd have to find the time and plug it into the velocity. So let's just do some things. Maximum height. And the maximum and the height itself. Don't forget to answer the question. Okay. Yeah, I like S I like H much better than S, but oh well. Okay, graph and calc zeros. Or use the quadratic formula. Calculator says this. Now what do? We want the velocity. So fine. Just as a final note, V should be negative when you're hitting the ground, because you hit the ground going down.